So last topic for the semester will be on methods. Method, we've talked about methods from the very first day. A method is a piece of code that's reusable. It generally performs one essential task, one specific task. It's basically a unit. Main is an example of a method that we've used from the very first day. It's the one method that every program is going to have. It's where our programs start. So we've put all our code inside of main so far. Well, now we're going to start putting code in other methods. So we go down and look at this. So of course that's what a Scratch program, a skeleton program looks like in Visual Studio. And of course that's main right here. That and the two curly braces. So let's look at the header. The header of a method is going to be this part right here. So the part that appears before the curly braces. And so let's dissect it and see what makes main a method. All right, so first of all, we start with the keyword static. Okay, static is what's known as a modifier. We'll talk about static a lot more in the next course. So in this course, we're not really going to talk about it, but every method we're going to create in here is going to begin with static. Later on, we'll see methods that don't begin with that, but not in this course. Next, in the next position where we see void there for main, that's where the return type goes. Now, some methods return things, and some methods don't. So main is a method that doesn't return anything. When main quits, when that method quits, that's it for your program. There's no need to return anything. So void indicates that nothing is returned. Okay, so we use void when nothing is returned. Okay, so next is going to be the method name. All right, so MAIN, and it's important that it's capital M. Visual Studio won't let you do anything else. Method names are going to be in Pascal case, which is also known as upper camel case, but I'll just stick with calling it Pascal. Everybody remember what Pascal case is? So Pascal case means that every word of that method name begins with a capital letter. So what are variable names? What case do they use? Lower camel, or just camel case. Some people just say camel case, but lower camel case. So the very first word of a variable begins with a lowercase letter, and every new word begins with an uppercase. We also have parameters, or at least we have a set of parentheses. So a method name always has a set of parentheses after it, whether there's anything in the parentheses or not. So we look at main, it has args. We call that a parameter, and we'll talk about what that means in a second. But what does that look like right there? Yes, that's exactly what it is. It's basically a variable declaration. Like if we put a semicolon after args, that's what if we took this out and put a semicolon after it and declared it somewhere else, it would look like we're declaring an array of strings called args. And that's exactly how this behaves. Now, in the case of string args for main, we're not going to worry about exactly what that means here. I mean, I could tell you, but it doesn't matter for this course. So we just always put that in main. Actually, it's always put there for you. Let's see. The definition for main is going to consist of the header plus the body. So those are some terms for you. We call that the method definition. So the method definition consists of the header, the part up here, plus the body, which is the curly braces and everything inside the curly braces. Writing our own methods. So just using the parts that we just discussed is basically how we're going to create our own. All right, so in this example, I've got, so this is the whole program right here, okay? And I've got, let's see, main is right there. And then inside main, in the body of main, is simply countdown in parentheses, semicolon. So I'm doing a method call. So we call it invoking a method or calling a method, same thing. Now, so what happens when this program runs is it's going to go down into main, and it's going to execute that line, which then causes it to come down here, okay, to static void countdown. And then, so it's going to go inside countdown, and it's going to execute this code that's inside, which is just a for loop that counts down from 10 to 1. So very simple. And totally arbitrary. I could put all kinds of code inside there. but that's what it does. So it's going to execute that for loop, count down from 10 to 1, and then it's going to quit, right? And once it quits, it's going to come, execution is going to return back up here and execute anything that appears after countdown, which is what? Nothing. Yeah, there's nothing. Okay? Because we're not going to drop down here and go back to countdown. Okay? So we just go back up here, execute anything that appears afterwards, which is nothing, so main just quits, and our program quits. And that's how it works. So we call a method, we go down to it, execute whatever happens to be inside of it, and then we go back up and continue on. So let's look at countdown real quick. So again, static, we'll talk about that in the next course. We do void. So, I created this myself and I declared it as void because I didn't need to return anything. So countdown just does something and then it quits. There's no need to return anything back to what called it. And we'll see some others in just a moment that do return things. Let's see, so return type void, and then the method name, again, we're going to use Pascal case, also known as upper camel case. So notice it's 2 words, both again with a capital letter. And then this one doesn't have any parameters. So we have parentheses, but there's no parameters, okay? Because countdown doesn't need additional information. We're going to use parameters when there needs to be additional information. So remember, main had parameters, it had args. Countdown has nothing because I don't need to send countdown any additional information. All it does, it has all the information it needs right here to count down from 10 to 1. It doesn't need to know anything else. Let's see, calling the method, we talked about that. Oh, and here's one of the benefits of methods. I mean, not only can we put code in these little units, we can call these units again and again and again. So in this example, I'm calling countdown 3 different times. I could call it 50 different times. I could put it in a loop and call it, every time that loop cycles, I could call countdown. There's all kinds of things we could do. What happens here, though, is I call countdown, it prints out 10 to 1, then it returns back. Now it goes down to the next countdown, prints 10 to 1, and then it comes back and then does the next one, just like that. Anywhere I want to call countdown, I can place it anywhere within my code, or, well, as long as it's like in main or some other valid location, and it will work. I can also give other people that method. If they might want to use it, I can create methods that other people can use and maybe put them in a library or something like that. It's a little bit more advanced, but we'll learn about that next semester. So now, and then a little bit about where they live. So we've got main right here in yellow. Below it, I have countdown. Notice they're completely separate. They have nothing to do with each other. I put countdown below main because whenever I write methods like this, where I put them in these examples, I like to put them down below main. So I created 10 methods. They'd all go. I put them at the bottom. Sometimes you'll see people write them above main. I don't like that style because main starts first. So it just makes sense that any methods you create would appear below it. Now later on, we're going to see better places to put methods. We'll put them in classes in different files, but for now, this is how we'll do it. Notice that they both live in the blue here, in the class called program. So a class is a unit of code where we can put similar things. Like classes hold methods, okay? Normally they'll hold methods that have a similar purpose. Like what's a class you can think of that we used so far? Been using since the first day. The console class, how about that? Console.writeLine, console.write, console readLine. The console class has methods that they all have a similar purpose, which is to deal with the console. What about the convert class? Convert to N32, convert to double. The convert class has methods that all have to do with converting things from one data type to another. So that's one of the things that a class does, is it houses methods that all have a similar purpose. So in our case, what we're doing now is we want to make sure that our methods are all housed within what's by default called program. And we can actually change that name, but by default it's called program. So just make sure it's located within these curly braces for the class. That's what I was trying to get to. It's very simple stuff. You just got to get used to it. Here's another example. So again, we're within the class program. So within those curly braces, I put a method right here. Well, that's actually countdown from before. And then I got another method down here called blast off. So when this program runs, it's going to go to main as usual, and we call countdown, which means we go down here and then print 10 to 1. We go back and then call blast off. So blast off, and then all blast off does is it has a little console write line in it, okay, that prints blast off. All right, so these are very simple methods. I mean, you know, you might not really implement something this way, but you know, it gives you an idea of what you can do with methods. Okay. Notice blast off is also another void method. It doesn't return anything. It just prints something out and then quits. That's all it does. What would happen if we did blast off and then called countdown? Would that work? So if instead of writing countdown blast off, what if I wrote blast off countdown? It'll work. It's not exactly logical. I would consider it a little bit of, well, I consider it a logical error because it doesn't really make sense to say blast off first and then countdown, but it's perfectly valid. So what would happen is just what I said. We put blast off first, and then it would say blast off, and then do the countdown. So it's functional, but it's not exactly what we would intend, right? So what the point is the order in which you call the methods is exactly the order in which they're called. So get your order right. Notice how clean main is right now. It's got those two method calls and all the other stuff is in here. That's one of the purposes of doing methods too, is like main will eventually become, you know, as you write more advanced programs, it'll just be a driver for your program, and it'll just have method calls, mostly just method calls, and it'll look much nicer. We can create all the methods we want. Let's talk about arguments. So here I have a program. Let's see, so there's main, and then I have square it, which I've created. And let's take a look at it right here. So right here, I am, you know, this is the method definition, right? So we said that, where we declare the header and then the body, that's called the definition. Inside the definition, when we put something in the parentheses, that's called a parameter, okay? When we put parameters, when that method needs to know some extra information in order to do what it does. So if you look at what square it does, is it takes whatever's sent to it, and in here, it squares it, okay? So what it does is number times number. So it's going to square that number that's sent to it. Now, if we didn't put anything in the parentheses, what do you think? What do you think would happen? How would it know what to square? It doesn't. If we just left everything else as is, it wouldn't know what to square. That's why it needs extra information. That's what a parameter is for. When we define the method, this is just some terminology for you. We call this a parameter. But when we actually call the method and send it something, that something is called an argument. So this is referred to as an argument. So when I make this method call, I'm calling square it and I'm sending an argument down here. Now, if we go back to countdown. Now, when we looked at countdown before, it was a parameterless method. It had no parameters, right? All it did was count down from 10 to 1. But if I wanted to mix it up a little bit, this is countdown from, and I've added a starting value. So this has a parameter that represents a starting value. So this one will go from whatever that starting value is that's sent to it down to 1. So it's similar to count down, but I've just added a little bit more. Now you see the difference why count down didn't need additional information, but count down from, we need to put a parameter with it so it knows, it needs that extra information. Otherwise it doesn't know where to start, from where to start counting. See the difference between parameterless and when you need a parameter? So the parameter here is an int. So it's important that the data type, the data that I send it, is the same. Okay? So what's going on here is that, so I'm prompting the user to enter a number. So right here we're going to do a console read line, convert it into an integer, and put it in number. Also notice I declared number like this. I didn't have to. Normally I put all my declarations up top. I don't know why I varied from that here, but anyway, this is no different than what we've seen before. So I'm going to read in that number, store it in number, Here I'm going to make a call to it. Let's say that the user entered 6. So I'm essentially sending it 6. We come in here. That value is going to be copied into this number. So it's almost like we're assigning that value from here down into this variable right here. And then I'm going to take 6 times 6, which is going to be 36, and I'm going to return it. So return is a new keyword. This is for a variable that returns, a method that returns something. We've got to have a return statement. So return is where, as soon as return is seen, that method quits and it returns whatever happens to be on the right, which in the case of number times number is going to be evaluated to whatever the actual number is. So like I said, for example, if it was 6, this would be 36 would be the square of 6, and we'd return that back up here. And it's almost like it appears in place of this and is then assigned into that variable right there. All right, so again, this is a variable, so we gotta make sure the data types match. All right, so like for instance, we could not send a double to this. Okay, this method requires an integer argument be sent to it because we have an integer parameter. Okay, so that type matches right here. Make sure they match. Now, actually, if number had been declared as a double in the parameter, could we send it an integer? Do you think? So if it was double number here in the definition instead of an int, do you think that would be okay? Now a double will hold an int, right? Remember that. A double can hold an integer, but an integer can't hold a double. So if I tried to call square it and send it a double, this would fail because an integer can't hold a double. But if instead I declared this as a double, I could send it an int and that would be okay because a double can hold an int. So when I say that data types have to match, there's some, that's a little exception right there. Only because a double can hold an int, but not vice versa. But if this had been declared a string and I tried to send it a number, that would fail. But otherwise, the data types, you have to make sure that the data type of the argument matches the data type of the parameter. Okay, so let me go over this one more time. So we're going to enter a number. We go ahead and declare a number, and we're going to store the number inside that variable. Okay. Now we're going to call square it, and we're going to send it that number, whatever that value is, which is then going to be copied into this. All right, so this variable is going to be declared when square it is called. So that value gets copied. It's like an assignment into that. Now we take that and square it right here and return it back up here. Now you got to make sure also that the data type of this matches the data type of this, because that's what that int represents. What's going to be returned? The data type of what's going to be returned. It has to match this. So when we don't put void here, we're indicating that this method returns something back to its caller. Okay? So that's what's going to happen when this return statement is seen. So it's going to return that back up here, and it's like whatever sent back magically appears there, and then is assigned into square. Oh, let's see, the other thing too. Now, this is something, notice that this is called number, and this is also called number. Why do you think I can do that? Normally I can't have two variables with the same name. Yeah, they're separate methods, exactly. Different scope. So this number, this variable that I declared has scope within main. It can be seen all within main and not outside of main. Same thing for this right here. It can only be seen within square it while square it exists. So this number and this number here are two completely different variables. Now I could have created a different name or different names, but I like to call them the same name because it's just easier that way. But just remember, these are two completely different variables. As a matter of fact, when square it is called, every time you call square it, this number right here is created, and when square it ends, it's destroyed. Well, I'll tell you one other thing too. One other thing that's important is, since square it is not a void method, it returns something. We need to do something with what was returned, because it's going to return something, okay? So what I did here, that's why I have this assignment. So when it returns its value, I'm going to copy it into square, do something with it. Otherwise, I just lose it. So when you have a method that returns something, you want to make sure you do something to return value. Here's another example. So I'm going to have the user enter two numbers, and then I've created a method called multiply. Now, this is an example of a method that takes more than one parameter. We can actually have as many parameters as we want. It just needs to be a comma-separated list. And here I have two integer parameters, a and b. We could actually have any data type we want. We could have ints, doubles, strings. We can even have arrays, any kind of data type. And we can mix it all up. It doesn't have to all be the same data type inside the parentheses. But here what happens is I'm going to call multiply, and I'm going to send it first, comma, second, which are these variables up here. First is going to be copied into A. Second is going to be copied into B. And then we're going to do our multiplication and then return that value back. Again, A and B are integers, which matches the return type here. So we return it and store it in product. Now, if we did this, let's see. If we made a call to multiply and sent it, if we mix the parameters up and said second and first, second would be copied into A and first would be copied into B. Now, in this case, it doesn't matter, because if you multiply A times B or B times A, you're still going to get the same answer. But there's other cases where it's going to mess things up. So you want to make sure that you send arguments in the correct order. Let's see, and then return types. Let's see, I think I already covered everything about return types. So whenever return is encountered, that method execution, the program execution goes back to whatever called it. So that method quits immediately whenever a return is seen. When you have a method that, in this position, if you have something indicating the data type that's returned, you're always also going to have a return statement. And again, we can use any data type for the return type. We can even use arrays and more advanced things we'll talk about later. The only thing about the return type is technically, well, for now, we can only return one thing at a time. So you can't say like int, comma, double, or something like that. You can only return like a single data type in this position. Only return one thing. And let's see, for a void method, I said we use void when we don't return anything, but you can actually use the return keyword even in a void method. So this is an example of it. So this is countdown like we saw before up here. And this is a slightly different version with return. For a void method, you just put return by itself. In this case, it won't make any difference. These will both do the same thing. But there are times when you might want to return based on some condition in the method. So like if this condition exists, then we put a return. What happens is the method immediately quits, doesn't execute anything else in the method, and it goes back to the caller. So sometimes it's useful to use return in a void method, but in a case like this, don't do it. It's just not necessary. In this example right here, anything wrong with it? Any comments about it? So I'm calling square it, just like we did before, same method, sending it a number. You see anything wrong about this though? Well, yeah, I know what you're going for. Yeah, you do want to, well, square it is a method that returns something, and you want to do something with what's returned. This actually will work. I mean, as far as syntax goes, C# has no problem doing it, but it's going to call square it with that number. It's going to return that number, but it's going to be, we're never going to see it because we don't do anything with it. Like what we did in the previous example was we stored it in a variable. We stored that return type, that return value in a variable. Here, we're not storing it or anything. Another thing we can do besides storing it in a variable is we can do something like this. So right here, I'm calling square it within a console write line. We haven't seen anything like this before. So remember, with string interpolation, we've got curly braces indicating that something's to be evaluated and not just printed literally. So here I've got square it number inside curly braces. It's going to call square it, and then it's going to print out the value that's returned. So this is one valid way to do it, but what's wrong with this method? What's the disadvantage of this method, I should say? It's perfectly valid, but there's a disadvantage. Since we're not storing it in a variable, once it does this and prints out, it's gone. I mean, we can't. The advantage of having a variable is we can keep using that variable again and again and again. But if we do this in place, it's only good for that one shot. Okay. But if you only need to do it once, this is totally valid. All right, let's talk about method overloading. So with method overloading, overloading is where we have methods with the same name. We have multiple methods with the same name. So this is handy where you want to have the same name for a method, but maybe you want to have a different return type, or you're going to have different parameters, different numbers of parameters, different data type parameters. Okay, so we can overload them. The key is to have different method signatures. All right, so the signature for this method right here is multiply int. So the signature is going to consist of the name, and then it's going to consist of the data types of the parameters. So if we're overloading methods, we have to make sure that those methods have different signatures. Here's an example overload. Right here, multiply that returns a double and it takes two doubles. And the signature for that is multiply double double. That's why we can have those overloaded. The signatures are different. They have the same names, but they have different signatures. Something like this will not work. Even though the parameters have different names, they have the same data types. So both of these have multiply, int as signatures. So these would not be valid overloads. We could not use these methods together.
What would happen if you tried to do that?
Oh, you'll get some compile error. You'll get a compiler error. You won't compile it. Or it won't compile, I should say. Let's see, this won't work either. Even though the return types, so this one has a return type event, this one has a return type of string, the return type is not a part of the signature. So these both actually have the same signature, multiply int. Now these, on the other hand, I've got, well, see, these are the signatures right here of all three of those. So that's why we can have all these three different methods. So I have multiply that takes two ints, I have multiply that takes two doubles, and then I have multiply that takes three doubles. So those are all valid overloads. The library method, so we talked in the beginning, we talked about the base class library. So anytime we talk about a library in programming, we're talking about a bunch of pre-written code that we can access. And the base class library has a bunch of important stuff that we've been using from C#. So like the convert class, the console class, math class, and whatever else we've used. So, we've been using these methods all along. The advantage is we don't have to write those. So that's one of the advantages of classes and also methods is that they can be reused, they can be given to other programmers to use, and that's what the base class library is all about. To use those methods, we just need to know the header and how the method functions. We actually don't even care about what's in the method itself, just the details of how to use it. If we look at this website, this Microsoft website, which is great. So this is all the information for the console class. If we look inside here, let's see, properties, go down to methods. So that is beep, and with no parameters, okay? And it plays the sound of a beep through the console speaker. Well, notice here I've got an overload of it. I've got beep. This one takes an int, so int32 just means int. We've discussed that before. So it takes two integers. It says int32 comma int32. So one, actually let's go into the details about it. If I click on it. So here's all the information for using beep that takes two parameters. Plays the sound of a beep of a specified frequency and duration. So it wants a frequency, it'll take values 37 to 32,767. And the second argument it'll take is an integer representing the duration in milliseconds. And also we see that it's a void method. Okay? So that's all we need to know is what to send it and what it returns, and then a description of how it works. We don't care about how it goes or what happens inside. But the reason why we have it overloaded is because, well, they give us two options. If we want to just do a simple beep, we can use this beep. If we want to do a beep that's more advanced, we can use this one. I mean, that's a good example of why you do overloads. If we go down to, I mean, look at right here. Let's see, where does it start? Right, there's tons of overloads for right. There's right that takes a string, an object. We haven't learned about objects yet. We'll learn about in the next course. But that's one overload, another, there's another, all kinds of overloads that take different types. And yeah, so depending on what you want to send it, you know, that's which one is called. That's another important thing about overloads. Whatever you send it, like if we go back here and look at this, if we call multiply and we send it 3 doubles, it's gonna call this one. It's not gonna look at the others. If I call multiply with 2 ints, it's gonna go to this one. Okay, period. Even though doubles can take ints, if we send it ints, since we have one that specifies ints, it's gonna call this one. Let's see, I think this is the last thing here. Whether or not to, now notice that some of these I call with some of these methods like console write. We always say console.write, so console is the class, right? And then, but when I created square it, I didn't put the class before it. And the reason why is because I need to tell C# where write lives. It doesn't know. Like square it, I defined it within the same source file, so it doesn't have to go anywhere to look for it. So I don't have to put like program.squareIt. Now if I took square it and put it in its own class file, which we'll look at next semester, I would have to specify the class. But since I put it in the same source file, I don't. But you know, console is not only is it not a, well, it's not a part, it's not in my source file, and it's not even a part of my project. It's in the base class library. So I have to tell C#, you know, look in the console class and find write, and then do this. And that's pretty much the difference between how you have to call it. And that's your introduction to methods. Any questions?